I apologize for not standing. I have some back problems, so I can't stand for a whole 45 minutes, so maybe a little bit more casual today. So I was given a talk last year talking about some of the new features that have been released in Entity Framework 8, Entity Framework Core version 8. And one of the biggest pieces of feedback that I got from that talk was people would come up to me and they hadn't used Entity Framework in a long time since the original version, which I call Entity Framework Classic or whatever it might be. But one of the most common things that they would say is, I had no idea that Entity Framework could do stuff like that. And as I thought about that, I thought, maybe it's time to give Entity Framework a revisit. A lot of people have put it off. That there's historically been a lot of problems that we'll talk about in a little bit here. But a lot of people have put it off for a while, so I thought I'd put together a talk about how maybe it's time to give Entity Framework another shot, to take another look at it. And so that was kind of the genesis of that talk. And just by way of introduction for myself, my name is Barret Blake. I am a Microsoft MVP, specifically for Power Automate in the business applications section. But I also like talking a lot about soft skills, about .NET, about a lot of other stuff as well. So, thinking about Entity Framework historically, it's had a lot of issues. And anybody who's worked with it could list off a bunch of stuff that they have had in the past as far as problems go. It was inefficient. It had issues with performance. It was easy to learn quickly, but to get into the deeper things took a lot of effort. It wasn't great at sometimes at migrating database changes, at schema updates, things like that. It was very heavily focused on code first development. It wasn't thread safe. The DB context wasn't thread safe, and there were just a whole host of issues that the people had with it. But when back in like 2014, 2015, they decided that it was time to redo .NET from the ground up, and that was the genesis of .NET Core. Well, they decided, at that time, that would be a perfect opportunity to rewrite Entity Framework as well, and to give that a new shot at life. And in 2016, the first version came out. And like any V1, it had a lot of issues. There were a lot of features missing. The performance wasn't great. But over time, over the last few years, it's iterated up through version 9 now. It has changed immensely. It has become a much deeper platform. There are a few features that we'll talk about here that didn't get carried forward from Entity Framework, the original version. And the performance is just orders of magnitude better than it was. So let's kind of touch first a little bit about the kinds of things that are missing from Entity Framework Core. EDMX, Entity SQL, those are gone. Those are things that not a lot of people liked. The file structure, working with some of the inner workings of Entity Framework, it wasn't great, and a lot of people didn't like working with it. The database first, that's pretty much gone now. You could do it fairly easily in Entity Framework Classic, but in Entity Framework Core you can do it, but it's mostly a one and done kind of thing. You can scaffold your entities from an existing database structure, but each time it's not incremental. You have to redo it from scratch every time. And there are a couple ways around that. I talked to a guy last week when I was presenting this at Conduct that mentioned that they were using like partial classes so that they didn't lose those changes when they had to rescaffold their entities. So there are ways of getting around that and working with that particular issue. The one thing that I do kind of miss a little bit is that there was a tool that you could install into Visual Studio that lets you edit your schema graphically within Visual Studio. That did not come forward, and I kind of missed that. But for the most part, all the other features that that you may have been familiar with Entity Framework, they're all there in Entity Framework Core now. And for the most part, they're all so much better than they were. And this is kind of a list of some of the new features on top of that. And I'm going to kind of be going through a lot of these one at a time, so I won't delve into them right now. But kind of going back to the classic argument, if we think over time, there have been two primary ways of working with data in .NET applications. You either had the Entity Framework crowd, and then you had the Dapper crowd. And those were the two, by far the two biggest groups. And there are of course, other ways of accessing data in that. But most of the time when I'd be working on projects, that was always the argument. We're either going to use Entity Framework or we're going to use Dapper, one or the other. And there were a lot of arguments back and forth, why you would use one or the other. And as we kind of get through this today, you'll kind of see that most of that is no longer a case. It's no longer the case. It's no longer an issue. Things like, working in detail with SQL, performance issues, memory issues. As we get through this, we're going to see that Entity Framework Core is on par with Dapper, neck and neck. There's almost no difference between the two these days. But performance, by far, is the biggest improvement. Yeah, there's a lot of features that I'm going to talk about, but the number one feature, if you want to put it that way, of Entity Framework Core over the old version of Entity Framework is performance. It is literally orders of magnitude faster than Entity Framework was. And we'll start going through some of these statistics here. And I'll start with kind of a comparison of Entity Framework versus Entity Framework 6, which was the last version of the old version, or the old type of Entity Framework. And these statistics that I found on a website where somebody had gone through and done a bunch of performance testing, this is actually with version 3 of Entity Framework Core, which is several versions ago, and the performance has gotten several times faster. But you can see even now, it was 2.5, 3 times faster than Entity Framework 6 was. Whether you're performing a single fetch or fetching huge lists of records, across the board, the performance was tons faster than Entity Framework 6 ever got to be. And it's the same thing with when you're sending data back to the database or the data source. Again, performance is 2 to 3 times faster at this point. And as we'll see, Entity Framework 9, which is the current version, you'll see is actually several hundred times faster than Entity Framework 3.1 Core, or Entity Framework Core 3.1, which is what these statistics come from here. But the one thing that most people want to know about is how does it compare to Dapper? Because that was always the biggest argument, I think, at least in the projects I was involved with, between the two, was Dapper was way faster because you're kind of down the core, or you're kind of down the metal, touching the SQL directly, you're writing it directly. But it's no longer the case. This is a comparison of Entity Framework Core 9, which is the current version, versus Dapper. And in single record fetches, you can see it's almost identical. In some cases, it's slightly faster. In some cases, slightly slower. But it's like 1 to 2 to 3% difference between the two. And the vast majority of what most of our applications are doing on a day-to-day basis are these single or small group of record fetches. So you can see there's almost no performance difference whatsoever between the two. The only time is that with Entity Framework Core, when you're doing a single async, for some reason, and I could not find anything which documented why this is the case, when Entity Framework Core is writing this single into a SQL statement, it's doing a select top 2 instead of select top 1. And I have no idea why it's doing that, and I couldn't find anything in the documentation or any record of why that's the case. But that's the reason that it's twice as slow as any of the other calls are. And that's really the only place where there's a difference in performance between the two. And again, looking at these performance of not just single record, but getting huge numbers of records. In this case, with this test, it was 14,000 items from a database table. And again, you can see that the performance between Entity Framework Core and Dapper was almost identical across the board. There was almost no almost no difference between the two. The biggest difference, as always, with Entity Framework is it's going to use a little bit more memory. The objects that it creates is going to create more memory just because of the way Entity Framework works with change tracking and some of the other features that are in there. So it's always going to have a little bit of a memory boost or a memory hit. But performance-wise, again, it's almost identical. And again, going back to inserts, updates, deletes, again, it's across the board. It's identical, and in a couple cases, even slightly faster than Dapper is. Here's another one on updates. So, when it comes down to it, what's left as far as the arguments between why you would use one over the other? As we can see, again, classically, performance. As we can see, performance is no longer an issue. The other classic argument was, with Dapper, I could write my SQL myself and fine-tune it, whatever it is. Entity Framework for a long time, even the old version of Entity Framework, you could write SQL yourself. You could pass that in. And as we'll see, that's actually, Entity Framework Core has actually taken that to the next level as one of the features I'll look at here in a little bit later. The only time that I think where there's really, there's like two places where there's might be one or the other. And one is if you're working with a lot of massive data sets. In that particular case, I probably would still use Dapper. Just because that slight edge, you're trying to get every little bit of performance boost between one over the other. If you're doing those massive data sets, hundreds of thousands, millions of records, I probably still would go with Dapper. But for any day-to-day application, any typical enterprise application, I'm probably going to go with the other kind of differentiating thing between the two of them, and that's features. And as we see here, Entity Framework Core really kind of wins hands down as far as features go. And then the first feature that I want to talk about is it's cross-platform. Just like with .NET Core, Entity Framework Core goes everywhere. It's Windows, it's Linux, it's Mac, it's OS, it's iOS, it's Android, it's TV operating systems, it's WASM in your browser. It's anywhere the .NET Core goes, which is pretty much everywhere nowadays, Entity Framework Core will go with it. So there's really no place almost that you can't use it. The next feature that I kind of want to highlight is one called property value conversion. So a common use case, if you have in your .NET code, you'll have a typical case of like an enum, where you have a list of items. And in this particular case that I have here on this example, I'm looking at characters on sci-fi television shows. And a lot of these characters are in militaries of some sort, and so they'll have a rank of some kind. So you have your enum that has captain, commander, general, sergeant, whatever it might be. And we know that typically when that goes to the database, Entity Framework Core and the other systems will turn that into an integer. And captain might be 1, commander might be 2, sergeant might be 3, whatever it might be. With Entity Framework Core, you can actually put in a converter in your context that instead of saving that as an integer, I can save it as the text string of that enumeration. So I can, when I go to look at my database data, I have to remember in my head, okay, well, in this particular column, 1 means captain, 2 means sergeant, whatever it is that, that I've created as far as my enumeration of my .NET Core goes. With property value conversion, instead you could save that as a string, so you could save that as captain, as commander, as sergeant, so that you don't have to remember that conversion in your head or go back and look it up again and say, okay, this means this and this means that. So what you use is this .has conversion fluent syntax in your entity model, in your entity builder. And you pass in basically 2 Lambda functions. The first one is when I'm converting from my enumeration to my database, that's the first function. In this particular case, it's just toString. And then the second function is what do you do when you're bringing it back from the database into your .NET entity. In this particular case, I'm parsing the strings that are coming back from the database and turning them back into my enumeration. That enumeration is probably just the most common example that's the most useful for us, but you can do any kind of property value conversion that you want. Maybe you want to do some custom business logic when you save it to the database and when you bring it back. Whatever it might be, you can do all that by defining that .has conversion in with your entity in your context. The next one that I want to talk about is entity constructors. So another kind of scenario is maybe, first let me say, typically Entity Framework, when it's initializing an entity, whether it's coming from data or whatever it might be, it calls that public constructor, the generic constructor, the one with generally with no parameters, and it sets each of the properties in that .NET entity one at a time. So in this particular case, if I have this this character class that has first name, last name, race, and rank, it'll call that public character constructor, and then as it's pulling in the data, it'll say, okay, first name goes in here, last name goes in here, and so on and so forth. What you can do is you can define another constructor, and as long as the parameters for that constructor match the names of the properties for that entity, Entity Framework will call that one first. The only difference is that the parameters on the constructor have to be camel case, and the properties have to be Pascal case. As long as that's the only difference between the two as far as the naming goes, Entity Framework will recognize that and it will call that constructor instead. And that constructor can have a private accessibility. So if you want to have a private constructor that only Entity Framework has access to, Maybe, again, you want to do some kind of business logic with the data that's coming back in from your data source before you initialize it into your entity frame or into your .NET object. Entity framework will recognize that. It'll call that constructor first. And then for any properties that are remaining that weren't part of that constructor, it'll update them the old way. So in this particular case with my private character constructor, it's got 3 properties. Entity framework will do that. And then for the last one, which is rank, it'll set that value the way that it always has. The only thing that you have to remember with this one is, aside from the fact that the naming has to be identical other than the casing, the only other thing is that if you have like navigational properties, things like that, or lazy loading properties, things like that, those are not supported in a private constructor. You would have to have that either be public or protected. But other than that, Entity Framework will automatically recognize that other constructor. It'll call that one first, and then it'll go on the same as it always has. Another common use case, especially if you're working with older databases, you'll have tables that don't have a primary key defined on it. Maybe it's a small reference table or some kind of table that has a bunch of data in it, but there's no primary keys, there's no unique indexes, there's nothing in there that you could use to identify that stuff. Well, in the past, it was very difficult to work with that stuff with your .NET entities and with Entity Framework. But now you can create a class that has the keyless attribute tied to it. And Entity Framework will be able to work with that data just the same as it would any other data source. So that's also another big improvement there. And kind of sort of related to that is what they call alternate keys. So another scenario is, you have a database table. It's got a primary key defined, but you may also have another field in that table where it's like a unique index or a unique constraint. And in a lot of database systems, those can be referenced from other tables as foreign keys. Well, again, in the past, Entity Framework didn't work with that really well. There was no way of identifying those fields as alternate keys. So they've come up with this alternate key process. So in your context in the model builder, you use that .has principal key to identify a field as an alternate key so that it can treat it just like a primary key would be treated. So again, Entity Framework is looking at these atypical scenarios that you might have to work with your database construction and providing you great ways of working with that structure. Another use case is you may have data in a database table that you don't want to be accessible in most scenarios. So maybe you have your main application and it's got a property that maybe it's like a record representing a person. And in the database table, you may have some PII data in there. And you need to be able to access and work with that data in your main application, but maybe you're also exposing an interface to an external application or to a client application of some kind. And you don't want that client application to know that these extra fields with personal information exist. So what Entity Framework has done is it's introduced this concept of shadow state properties. So again, this is something that's maintained entirely in the context class. And what you do is you define in your model builder a property, you give it the type and then give it the name and say, okay, for in this particular case, my character, with the example that I have on the screen here, I've got this field called last updated. I don't want my character class, my character entity in .NET to know that the last updated field exists, but I still want to be able to access that information or update that information as needed, maybe from an administrative interface that has access to things that aren't available to the application as a whole or to client applications that might be accessing your application. So by using the shadow state property, I can still access that information maybe from an administrative screen. I can still see that it exists, and I can still make updates to it, and I can still treat it like any other property in that class would be, but only if I actually know that it exists, if I know that I've set it up in my context, and if I know what the name of that property is. So there are other ways to do that, to keep that kind of information hidden. But again, here's Entity Framework providing you a fairly easy way of doing that through its interface into your data. Another scenario is a lot of times we may have computed columns, and these are fairly common in various database systems. And in the past, any framework hasn't given you a really good way of recognizing within your .NET code, well, hey, this is a field that the database handles. This is a field that the database calculates. I shouldn't be able to mess with that. Generally speaking, within my .NET code, I should only be able to maybe read that information. They've added this attribute database generator, which basically gives you a good way of flagging those particular fields and saying, hey, this is something that's handled in the database. Maybe it's a computed column, maybe it's an alternate index of some kind, unique constraint, an identity field, whatever it might be. This will tell your .NET code, hey, this is something that I don't want to mess with, but it's there for me to access. Another fairly common scenario is maybe I have multi-tenant scenarios. So maybe a good example that I think of, I've got this API application that serves as the back end for multiple websites. Again, kind of going back to my sci-fi thing, maybe I've got this sci-fi where I've got all the data on the back end with a single database and a single API. But on the front, I want to have different fan sites. I've got a fan site for Babylon 5, a fan site for Star Wars, a fan site for Star Trek, whatever it might be. And they all hit the same API. But I want to make sure that data is generally kept separate as far as when I'm accessing it. Well, Entity Framework has the concept of global query filters. So what you can do is you can, on your entities, you can define a filter that gets applied anytime that a query is made against that data. And you define this in your context using the .has query filter and then telling it what the query filter is. In this particular case, if I was doing this scenario where I've got this single backend for multiple websites, I would probably create some kind of service that identifies as the calls are coming into my API. This call is coming from my Babylon 5 site, so I want to filter it to Babylon 5 data. This site's, or this call is coming from my Star Trek site, I want to filter it to my Star Trek data. By having that global query filter, you're able to easily add that kind of filter to the data query, and you don't have to worry about that in your various LINQ queries. You can just put in one filter, and that takes care of it for each of the entities. There's a couple of caveats with this one as well. It has to be applied only at the top level of a hierarchy. So maybe I've got like my characters table, and I've got a seasons table, and both of those reference another table that's got a list of episodes. So my seasons might have, here's episodes 1 through 20, and characters might say, oh, this character was in this episode, that episode, that episode. So you can only apply that query filter to the very top level of that hierarchy. You couldn't add it to the episodes table. You'd have to apply the query filter to the top two tables. So that's the biggest caveat with that, and kind of gotcha. Another common scenario with that is like soft deletes. That's a fairly common thing in a lot of applications these days. And the process for implementing soft deletes is generally fairly manual. You have to remember that and say, okay, well, when do I want to get stuff that's flagged as deleted, and be able to update that and do that. Global query filters give you another way of making that really easy for yourself so that you can apply that filter and still be able to pull in the data that you want usually, but still be able to override that in the situations where you need to. And the way that you override that is when you're doing your LINQ query, you have that flag .ignore query filters. And basically when you pass that in as part of your LINQ query, that's telling your context, okay, ignore the query filter that's there and just give me everything, as far as that goes. So again, it's fairly easy to override when you need to, but in general, it gives you a great way of filtering out your data as needed. I've mentioned before that for a long time, Entity Framework Core has been able to do raw SQL queries, and going back to the olden days, I've been around a long time, but that was one of the most common arguments between Dapper and Entity Framework in the early days of that kind of development is, Dapper lets me handle the SQL myself, Entity Framework, does that for me. Well, for a long time, Entity Framework has been able to do the raw SQL queries as well. So you didn't really need to you didn't really have that as a differentiation between the two. But with some of the more recent versions of Entity Framework Core, it's taken that to the next level. You have these scenarios where you can start with your raw SQL query, and then you can apply LINQ to it. So I've got my select star from characters. That's the basis of my query. And then I've got my .where clause, my .include clause, or fluent syntax. And I'm able to apply that all together, make it all work together, and it's all seamless for me. I don't have to worry about it. And Entity Framework will figure out on the back end, okay, do I just get the characters first and then apply the LINQ to it, or can I turn this into a single query statement? It handles all that for you so you don't have to worry about it, and it makes it in the most efficient way that it can. It's also, oh, sorry, that's later on. As we'll see later on, there's a couple other additions to that I'll show you here in a minute. But first I want to talk about batching. So we've got, here's another common scenario. I want to get my characters and I want to change the race to human for all these characters. Well, if I have 500 characters in my database table, that's going to be 1,000 calls with the upper version of that, because it's going to do 1,000 selects to get the records. And it's going to do, or not 1,000, it's going to do 500 selects, and it's going to do 500 updates. And Entity Framework, in the past, we'll figure that out, how, what's the most efficient way? Do I send that 40 at a time? Do I send that 100 at a time? The database provider that's in there will help it figure all that out, so you don't have to. So it does it in the most efficient way possible. And that efficiency has improved significantly over time as we've gone through the various iterations of .NET, or of Entity Framework Core. But with version 7 of Entity Framework Core, they introduced a couple of new statements, and that was the .execute update and execute delete, and async versions of each of those. And what that will do is it will bypass the change tracking that Entity Framework normally does. And while these two examples, the top example and the bottom example, both do the exact same thing to my data, the one at the top is 1,000 calls to the database. The one on the bottom is 1 call to the database. It writes that as a single update statement, and it just sends that together because it's saying, hey, because I'm doing this execute update or execute delete, I can skip the change tracking. I don't need to worry about that, so I don't need to get in the information beforehand. I'm just doing that update. And so it does it as a single call, and it gives you that performance boost. So it's one of those that it's there. It's only going to be useful in certain scenarios, but as long as it's doing what you're expecting it to do, it's a great way to boost the performance of your application. And again, of course, you can use all the various LINQ with that, if you want to filter down to with where clauses and whatnot, and it'll update that statement appropriately. The next thing is DB context pooling. So, a DB context in and of itself is a fairly lightweight object. The real struggle with DB context is with that initialization. That's where most of the performance hit comes. That's where most of the memory hit comes. That's where, whatever it is that you set up there, whether it's, if it's a fairly complex setup, it can take several hundred milliseconds, and that can have a significant impact over time, because that context gets generated with each call to it. It gets regenerated. That initial slowdown of the initial setup can really have, over time, a significant performance impact. Well, what they've introduced now is this context pooling. So basically what this does is this takes your DB context, and it says, okay, when my request is done, I'm not going to dispose of that anymore. I'm going to keep it in memory. I'm going to keep it around so that the next time I need a DB context, I'm just going to pull this one out of memory that already exists, that's already been initialized, and I'm going to reuse that context instead of generating a new one. Basically, it's basically turning your DB context into a singleton instead of being regenerated each time that you need it. And by default, or the way that you do it is use this .add DB context pool. So you're saying, okay, instead of having these individual instances that get regenerated each time, create this pool of instances, and you can define how many you want in that pool. By default, it's like 1,024, if I recall correctly. But you can set that to whatever value that you want. You say, maybe I want to keep 500 of these around. instead, when it needs one, it'll go to the pool and grab one out of the pool and say, I've already got one, use that instead of generating a new instance. The biggest thing to remember with this is all that initialization only happens on the first time that it gets generated. So if you're doing anything with like state management, any initial setup that's part of that DB context, you've got to remember that that only happens the first time. So you need to be careful with how you're creating that. So if kind of going back to our example of the multi-tenant scenario, with like the global query filter, if I'm keeping track of my tenant information, within my DB context instead of like some other outside service or something like that, when it comes back and it grabs one of those contexts out of the pool, it might be grabbing the wrong one. So maybe I want the version that connects to my Star Trek site, and it grabs one that was connected to the Babylon 5 site. So as long as you're careful with how you set up that initialization, and as long as you keep in mind that only happens the first time, and going forward when it gets pulled back out of the pool, it's going to have that information from the last time. So as long as you're aware of that, as long as you're keeping track of that and being careful with that, then it's a really good way of getting you that little bit boost. And again, it's not, individually, it's not a huge performance boost, but over time, especially if you're doing a lot of small requests instead of a few big requests, then that performance boost really adds up over time. One of the features that was part of my talk last year with Entity Framework version 8 is a concept of complex types. So, here's another common scenario. You have a customer, and that customer has an address. Typically in the past, this would be stored in the database as two different tables with a parent-child relationship. You'd have a customer table and an address table. Well, if that relationship is a one-to-one, and perhaps address isn't the best example of that, but say you've set it so that the customer only has a single address, as in this example here. If that relationship is a one-to-one, you can define that child class as a complex type. And what it will do when it goes out to the database is instead of storing that in two different tables with a foreign key relationship, instead it will put them both in the same table in the database. And you get here's an example of that flag. So you'd add the attribute of complex type on the child type. And then when it goes out to the database table, what it will do is it will use that prefix of address underscore city, address underscore state. And it's putting it all in the same database table and saying, hey, because these things are together, because I want to follow my normal database normalization, because, database, and that's one of the problems with programming, is database normalization doesn't always match the way you want to construct things in your .NET code. But in this particular case, Entity Framework is saying, hey, you can still have your database normalization, following the rules that are defined by doing it this way. So if I define it as a complex type, I'm sticking them all in the same table because it's a one-to-one relationship, because it's all related data. And you can nest that as well. So maybe under my address, I want to have another class under the address class that's maybe geocoordinates. And I can define that as a complex type, and it's got maybe a latitude and a longitude in it. And then when it goes out to the database, when it's adding that, it'll be address underscore geocoordinates underscore latitude, address underscore geocoordinates underscore longitude. And you can nest those, I think it's 5 levels deep, I think is the maximum that's allowed. I don't recall specifically off the top of my head now. But if you have these, one-to-one relationships and you want your database, we always get in these arguments with the database team. If you have these DBAs that will say, okay, we have to do it this way, but you say, no, I want to write my .NET code this way, and you get that back and forth. This is a great way of bringing those two concepts together, and you don't have to worry about it because Entity Framework will just take care of it for you. Similar to that is primitive collections, which is another concept that came out of Entity Framework Core version 8 last year. And here's another example of where we might have a list of primitive types. Maybe it's a GUID, an integer, a float, whatever it might be. And then, in my .NET class, I've got those, just as there is a list of GUID in this particular case. But when you go out to the database table, in the past, Entity Framework would store that as a child table again, with a parent-child relationship. And it would maintain that in the background. And when you look at your database structure, that's how you would see it. Well, with primitive collections, which came about like I said, in version 8 last year. What that will do instead with these primitive types, if you have a list of primitive types, is it will convert those into a JSON formatted array of strings. And it will store them in a single string field in your database table, in this customer table. So you get a database schema that looks like this. So I've got my wish list products. It's an nvar max. And if I've got a list of GUIDs, here's an example of how it would store that in that field tied to that customer. So it's all there. It's all in a single table. It's all together. And the way that it does that is because of all the vast improvements in support for JSON objects that have come in the recent versions of both SQL Server and Oracle and some of these other databases, as well as on the code side with Entity Framework Core. It's able to take advantage of things like open JSON queries and able to implement it in this way. And actually, in Entity Framework nowadays, we'll do this by default now. This is the default way that it will store that data if you're doing your code first database structures. So as far as using it with your LINQ queries, it treats it just like it's a list. It's something where you can do your LINQ queries just like you always have. And on the back end, it takes care of that by using that open JSON logic and functionality, especially with SQL Server or Cosmos DB, some of that kind of stuff. One of the other things that this will let you do with this is, this is a common scenario too, is say I've got a list of customers and I want to look for all the customers whose first name falls into a list of names. Well, Entity Framework has always been able to do this kind of query, and it works. The problem is that when it goes to the back end, when it goes to SQL Server and the other databases, it will do it as a static query, or a static where clause in the query. So it'll say, where first names in, and list out John, Jane, Jim, Jill. And because of that, if that list of names changes, when you're making that query against SQL Server, it doesn't take advantage of cached query plans on the SQL Server side or on the other databases side. Well, what Entity Framework will do now with the ability to use again this open JSON functionality that is supported in the more modern systems is it will now pass in that list of names as a parameter. And it will be able to take advantage of that, cached query plans in SQL Server now. So again, on the .NET side, it looks the exact same. But on the SQL Server side, it's now able to take advantage of these things that will give you could be potentially a significant performance boost. So that's another advantage that these primitive collections and Entity Framework being able to understand how that works and making use of these open JSON functionality gives you that big performance boost that's tied on the back end, not so much on the front end. Another one, this is where you're going to get kind of a small performance boost is compiled queries. So typically, when the first time that you pass a LINQ query into Entity Framework, it has to compile that into a SQL statement. And that takes some time. But what you can do now, and that happens when your application is running with a just-in-time compiler. What happens now with compiled queries, if you want to do it that way, is you can say, okay, I don't want you to compile this query at runtime. I want you to compile this query in advance at build time, when I'm doing my build in Visual Studio or VS Code or whatever it is. So you can pre-compile essentially these queries that'll convert it into SQL and it'll store it in your code. So it's got that information in there. And the way that you do that is with this ef.compile async query command, which basically you're passing in a Lambda function essentially and saying, okay, I want to approach it this way. I want you to compile it in advance. And as you can see from the statistics here, it's not a huge performance boost. But again, if you're doing hundreds, thousands, millions of small individual queries, that can give you an incremental performance boost over time. It can be a huge advantage for you. So again, every little bit is out there, and they're giving you all these different ways in order to advance and improve performance, not just internally, but with the way that you write your code. And kind of the last group of things, there's things that I didn't want to go into in significant detail. There's things like field mapping. So, you know, if you're doing like XAML or WPF, where it's got this concept of the watched properties, you know, if like iNotify property changed, the way the entity framework would work with those in the past is that it would, with that initialization, when it's creating those instances, it would already flag them as dirty, as objects that needed to be updated. With field mapping now, and there's more details in the documentation about it, you can set it up so that it doesn't do that, so that it doesn't start off its existence thinking that it needs to be updated to the database. There's improved support for nullable reference types, which has been around in .NET for a while, even though the documentation still says new. There's you know, eager loading for derived types. You know, when you're using the .include, say you've got a student that is a type of person. That didn't always work well with .NET or with Entity Framework in the past. Well, now there's a lot better support for that. There's a lot better support for await for each statements. So if you've got an await and then in a for each loop and it's doing these queries, sometimes Entity Framework would get into these like race conditions and it would just basically freeze up and have issues. Well, there's support for that now. That's much improved and no longer the issue that it was. There's more data sources. Cosmos DB is fully supported now with version 9. There is support for in-memory data sources. They don't recommend that you do it as a production environment, but if you wanted to set up, especially for like unit testing, if you wanted to set up an in-memory data store to do your unit tests against actual data instead of mocks, then that option is there for you. And God help you if you want to support JET for Access, Microsoft Access, that support is there for you now too. And as I mentioned, there's a lot of better support for JSON now across the board. So kind of bringing this all together, you know, in the past, there have always been these two camps. You know, you've got, for the most part, there's been the two camps. There's the Entity Framework camp and there's the Dapper camp. Well, as you can see now, the differences between the two are completely gone now. You know, performance-wise, Entity Framework Core is almost identical to Dapper across the board. Features-wise, you know, and I talk a lot about LINQ and these other features that Entity Framework Core has. Well, there are libraries that let you use LINQ with Dapper as well. So, you know, there's a lot of things that bring kind of together, and there's not really that much of a difference now. But as far as out-of-the-box features, as far as, you know, getting started and you know, ramping up really quickly, Entity Framework Core has that slight advantage. Some people say, well, okay, Entity Framework Core takes away from not understanding SQL because you don't have to understand how SQL works. Well, yes, you know, as far as the initial process goes, as far as getting ramped up goes, that's true. But every developer who works with data in any form, which is almost all of us, really needs to know and understand how SQL works. So even though Entity Framework kind of hides a lot of that from you most of the time, it's really something that you need to invest the time in learning yourself as well. So again, that's not really an argument one for the other. So there's really not a difference now between the two camps. So you know, maybe it's time that you give Entity Framework Core another look. Thank you. If anybody has any questions, of course, there's the Discord. I'll try to answer questions out there. You can reach out to me on Blue Sky, LinkedIn. My website is up here as well. So.